Hi everyone. Today I want to talk about electron impact ionization. It's used in mass spectrometers and it follows a very simple format. And we're talking about mass spectrophotometers. You have a way to get molecules, usually a gas. You're going to ionize them in an electron impact ionizer. And then you're going to bring it to the mass analyzer. So in my previous tutorials, I've talked about the mass analyzers. You can see them. They're my most previous two videos. But today we're going to be talking about this here, the mass impact ionizer. Now there's other ionizers out there, but this one is going to be a big focus of any instrumental course you may be taking. Man, this is a chalky eraser, but how exactly does an electron impact ionizer really work? Well, first you need a gaseous input of ions, so accustomed to all of these diagrams we've been making, these block diagrams, we need to have an input. And this input is going to be gaseous molecules. So for example, you would need stuff like, let's say you're doing a mass spec of butane, and you have butane. Well, you need to have that in the gaseous form coming through. Okay, hopefully that's pretty simple to follow. But you're going to put it in this nice reaction chamber. That looks like this. We'll get to what these two things are in a moment, but the output of this thing, this is going to end up going to your mass analyzer, which again we discussed in previous videos, but mass analyzer. So you have your gaseous molecules come in. They're going to pass through this thing that we'll discuss later. It's going to go to the mass analyzer. Hopefully you can follow that. It's not anything too difficult. But think about the name. This is an ionizer. We need to ionize these gaseous molecules coming in. And in fact, we actually fragment the molecules themselves when we do this. But what we're doing, we have this little mechanism here. And this, when we talk about these little curly things, it's usually a filament we're talking about. And typically this is a tungsten filament. Okay, so we have this tungsten filament fitted in this first little subsection of the of the electron impact ionizer. At the bottom we're going to have an anode, so it's excess of positive charges. Okay, so I'll just label that anode. And at the tungsten filament, we're going to heat the tungsten filament. And when we do so, we go from tungsten, right, given some input energy delta, we're going to get a tungsten 2 plus and 2 electrons, okay? That's the reaction that's going to happen. So outputting of this filament is not light, but instead electrons. And notice they're going to an anode. So electrons are negative, you have a positive anode. The electrons begin to bombard the anode. So you get this flow, this beam of electrons flowing from the cathode to the anode. Okay, so we have that described. Now we need to describe what's happening as the gaseous molecules move from the region to the other region through this stream of electrons. I want to make another thing clear, just the voltage difference between the filament and the anode. The electrons are going to move through 70 volts of energy. Okay, so they go from a really, really high potential of 70 volt down to 0 volt here. So I just want to make that clear. It's moving through a pretty high potential. So these things are really going. I'm sure we could figure out, the velocity maybe in the middle just to see, okay, when it's impacting the beam, what's the kind of speeds we're talking about. But notice, as we go, I'm going to erase this if that's okay. I need to make some room to describe what's happening. We have electrons bombarding the flow of ions, which is going this way. So they're making a right angle to each other. And if you hit these molecules with enough energy, these electrons have enough energy, they're going to get so close. Let's say there's an electron hanging out in an orbital, maybe right here. It's going to push this electron out. Okay, so this electron gets shot off of the molecule. And what we're left with is this, we call it a radical carbocation. Now, as this thing is getting shot through the mass electron ionizer, it can fragment and undergo all these things, but we're not going to really talk about that right now. But we get this radical carbocation, so it has a positive charge to it because we shot an electron off. Now we need to talk about the plates. Okay, what's up with these plates? Well, they actually have a charge to them. This plate we're going to hold at a positive charge. In this one here, we're going to hold it at a negative charge, and same with this, also a negative charge. Well, think about what's happening to this molecule as it's positively charged moving this way. Well, if you remember from physics 2, what happens when you have a positive charge and a positive charge, it's going to accelerate. It's going to act a force via an electric field. This is actually an electric field, positive to negative, right? It's going to accelerate these radical carbocations through this mass analyzer. And notice, a positive charge, it gets attracted to the negative, but then we have a negative plate here as well, and it's going to be further accelerated. So what's happening in total is we have these molecules with some velocity coming in, they get hit, they get ionized, and then they get shot through this ionizer. And because they're getting accelerated by an electric field force, and it gets shot through to the mass analyzer. Now, hopefully you can follow this. I know it's quite a bit going on. Hopefully that recap was helpful. But remember, the main mechanism you need to know is the electron bombards, shoots an electron off. You get a radical carbocation. And in fact, you can get some fragments. You could get, for example, a methyl fragment. You could get a ethyl fragment. You could even get a propyl fragment. And in fact, if this thing doesn't fragment at all, if you let this go through the mass analyzer and you pick up in the mass analyzer that, you might even get a butyl fragment or some isomer of a butyl fragment, right? Maybe because this is a little too not nice having a primary carbocation, maybe you shift it to a secondary or something like that. But in essence, that's what this electron impact ionizer is doing. So hopefully you could follow that. If you did, please drop a like, comment, and subscribe. I'd greatly appreciate it. If you have any questions, drop them in the comments below. And I hope that you have a wonderful day. Bye-bye.